Hi, welcome to this video on polynomial regression. This is the last lesson, lesson 6 in our unit 1C, and I'm going to talk about how to enter and find a regression equation for all of the polynomial functions using two graphing software, Desmos and TI Inspire. Okay, so what we're learning, create an appropriate mathematical model using technology and then be able to answer questions about that context. You'll be successful if you can create a regression model using a graphing calculator, pretty simple, and then you can use that regression in order to make a prediction. Here in my notes, these are just steps specifically using the TI Inspire about how to create a regression. Again, I'll go over that in this video, as well as being able to evaluate that regression model. I'll also go ahead and again show you using Desmos. Okay, but these are here if you want to pause and read or just look at those notes. Let's go ahead and let's jump into an example. This example says the table shows the distance d in meters an object has traveled at time t seconds. In A, they say create a linear regression for a model for this situation. Very important to note if a question is asking you to create a certain type of regression. Here they say linear, so we'll go ahead and do that. I'm going to open up Desmos, and Desmos, you're going to make a table. So this plus button here, you're going to make a table and you're just going to enter this data. So my input values were 1, 3, 6, 11, and 17. The output values, the distance, was 1, 9, 20, 42, and 75. So once you have your data entered in a table, and you'll notice once you enter it, you get the points plotted, the specific points plotted here. There's a little button with dots here and then a line through it that says Add Regression. You want to click that, and it has a drop down here and it says linear regression, quadratic regression, cubic regression, quartic regression. This process is exactly the same for all of these regressions, regardless of what data set you have. Just whatever type of regression they want you to find, you would select those regressions. Okay, we do want a linear, so I'll click linear, and you'll notice over here we have a line that goes through our data, and then right below it is an equation. Y equals 4.59211x minus 5.5. Guess what? That is your linear regression equation, okay? And so I'm going to go ahead and jot this down. Y equals 4.59211x minus 5.5. Okay? And again, because this is modeling d of t, you could even do something like this. You could say d of t is equal to or approximately this value, okay? Now B, they say use your model to determine the distance in meters an object will have traveled at 90 seconds. And actually, if I want t here, this x should be a t. Anyway, but there's my regression, okay? And so we want 90 seconds as an input. So what you want to do, especially if you're using Desmos, click this button right here, and it says export a snapshot to the expression list. And so notice it will take this function down here. This is nice because it uses all of the values and then it doesn't round. You do not want to round. You want to use as many digits as possible to prevent a rounding error. So what I'm going to do though is I'm going to change the output from y, I'm going to call it d, based upon x, d of x. And I do this because what it allows me to do now is evaluate this function. So I can say, okay, what is d, the distance, based upon 90 seconds? And right away it gives us our answer. So this would be 407.7899 or 790. And our units for this were meters. So there you go. There is your answers. And I do like to do this. So d of 90 equals. Explicitly say what you got from your calculator. Okay, so there's your answer. And then C, use your model to determine at what time in seconds the object will have traveled 58 meters. So here, they give the distance. They say the distance is 58 meters. What time has passed? And so this is graphing, solving by graphing. I can graph another equation, y equals 58. And I don't see it because notice my y value is 5, 10, 15, 20, 25. I can scroll or I can zoom out and we'll see it here at 58. So there's 58, and I find the intersection. That's where my graph, right, this is my regression of d, equals this height of 58. And so that time would be 13.828 seconds. 13.828, and that is seconds. Okay, there you go. That is how you do a regression with Desmos. Pretty simple and straightforward. I do want to also go ahead and show you with a TI Inspire. It's a little bit more cumbersome. You're going to create a list or a spreadsheet. So this should look familiar. So again, I'll enter my data, 1, 3, 6, 11, 17. And I do have to title this column. I need to title it a certain variable. I just keep it simple, X, and then for this column I use Y, and I'll enter my output data, 20, 42, 75. And then how we create a regression is we can click any cell next to the data, and you're going to click Menu, Statistics, and it should be Stat Calc. Something funny is going on here. Hold on, let me get out of this. Okay, I'm not going to double click to where I can see the cursor. Just click on it once. It's highlighted, Menus, Statistics, Stat Calcs, and then you can see all of the regressions here that you can run. Again, linear, quadratic, cubic. There's 2 linear regressions, and they don't make a difference. The only difference between them is, I guess, the commutative property. One put the slope times the input variable first. This one, a plus bx, puts your a value first. We'll go classic, mx plus b. And then it'll say, hey, for your regression, what do you want to use as your x list? I want to use the first list, x. What do you want to use as a y list? I'll use y. And then it says save regression equation 2, and you can title this a different equation. I don't mess with that. I just let it do that. And then you can see here, okay, here's your slope, your m value, 4.592, which is what we had, and then your b value, negative 5.5, there it is, okay? And if I wanted to go ahead and evaluate using this equation, I can add a calculator, and that equation is stored right here under this button, VAR. And so you remember how it said store regression equation 2, F1? Well, there's my equation. So again, you can change it, and it would title it something differently, but if you know what it is, F1 of, and they wanted, okay, what was the distance after 90 seconds? So I hit enter, and there you go, 407.789. Now you can also, again, do the second part. I can graph this regression equation. If I open up a graph and I say, hey, I want you to go ahead and I want you to graph F1 of x. So now I'm going to go ahead and graph this equation, again, from the same place that I used it in the calculator. I'll hit enter. There's my linear line. And then if I want to find the intersection at 58, right, because the second question said, hey, what time will you have a distance of 58 seconds? I can graph 58. Again, I don't see it because I'm zoomed in. So let me go ahead and change my window. Window, zoom out. So I can zoom out. And once we hit 58, there you go. And I want to find that intersection. So I'm going to go Menu, Analyze Graph, Intersection, and left, right. And then there is your answer, 13.828, which is what we got here. What do you like? Do you like Desmos or do you like TI Inspire? Okay, they both do the same thing. Desmos is a little bit more user-friendly. TI Inspire has some bells and whistles that Desmos doesn't have. Okay, so anyway, here is a practice problem. Please go ahead, pause this one, and then I'll show you the answers here. Okay, here is the quadratic regression model that I got for this situation. Again, I went to Desmos, I entered the table here, and I had to change from linear to a quadratic regression. And again, you can see that equation given here, okay? So, and actually, technically I'm going to change this. That's V of R, my input should be R. I'll just put X. Part B, use your model to determine the volume of the tank with a radius of 8 feet. Go ahead, figure that out. I'll show the answer here in a second. Okay, I want the volume where the radius is equal to 8 feet. Radius equals 8, so we find V of 8. I'm going to go to Desmos. I'm going to copy this equation down, and I'm going to change, again, that output to, you can title it anything, but I'll call it V of X because we're talking about volume. And this is I want V of 8. So I get 3015.57997. Let's just use 5 decimals. Okay, so here's your answer, and this is volume in cubic feet, feet cubed. I always like to include units. Okay, C, use your model to determine the radius of the tank with a volume of 800 cubic feet. Okay, I'm going to graph 800, y equals 800, and I'll find the intersection. So I do got to zoom out. Woo. There it is, and now I'll zoom in. I have a positive and a negative answer. I don't care about the negative answer because contextually you can't have a negative radius here. So I'm going to say, okay, I want V of R equal to 800, and then R is equal to, that value is 4.1208. And that is going to be in feet. Okay, there you go. Radius is 4.1208 feet. That's it. Hey, in this video, we went ahead and we learned how to create an appropriate mathematical model using technology, specifically regressions. For Desmos and for TIs, it's the same. Make a list. With those lists, run a regression. Make sure you select the correct regression. 2 things they'll usually have you do with that. They'll have you evaluate that function at a certain value for the input, or they'll have you graph that equation and then solve for the output or the intersection of those. Okay, give a thumbs up if you learned something in this video. See you in the next one.